Okay, when we are live. Good morning, Dr. Dave.
Good morning, Mr. Tim.
All right, I see a lot of people still filing in, so hopefully by the time I get through our intro here, we'll have a nice full lobby and we can get her going. But otherwise, good morning and afternoon, everyone. Thanks for taking the time to join us today. My name's Tim Kopp. I'm with the Fluence marketing team, and I'll be moderating today's session. So this morning, we're talking about a new approach in cultivation. At Fluence, often what we do starts with a simple question. How can we help growers produce more high quality cannabis with less energy and less risk? Over the last decade, our research at places like the Fluence Cannabis Science Center and in partnership with commercial growers around the world, we've been studying how light intensity, spectrum, and distribution behaves inside and under the canopy, not just above it. Today's session is a high level introduction to the science and strategy to what we've been calling the red sandwich. We'll walk through the research and discuss how this approach can fit into real-world cultivation environments, whether you're designing a new room or optimizing an existing one. Leading today's discussion is Dr. Dave Holly, Principal Scientist and Head of R&D here at Fluence. Dr. Dave and his team of cannabis crop scientists have become pioneers of the field, spearheading cutting-edge research on horticulture lighting, controlled environment systems, and cannabis cultivation. Finally, before we get started here and as we go through today's session, I'd like to invite everyone to submit questions by using the QA button that you'll see at the top of your screen. We'll be leaving plenty of time at the end to answer any questions that come through. As a side note, we'll also be making this recording available in the next couple of days on our YouTube channel and on the Fluence website. So get comfortable, sit back, enjoy the show, and without further ado, Dave, I see a lot of hungry folks here.
All right, thanks, Tim, and hi everyone. Let me start by thanking you for your time today. I know it's busy, and I certainly am going to do my best to make this worth your while. So, like Tim said, my name is Dr. Dave Holly. I am an environmental scientist, and today I'm speaking to you in the role of the principal scientist and head of photobiological research and development here at Fluence. There's a good chance that if you're here, you've seen some of our webinars in the past, and there's a good chance that you are familiar with some of our talking points. In the past, we've talked about light intensity, and we talked about spectrum, and we talked about light distribution. And you've probably also heard our consistent messaging that everything that we do is led by science. It is our tagline, but it's also the way that we do business. It's a pretty simple model. We do objective research on whatever we think could be a value add for crop production, in this case, cannabis. And if there's an ROI for it, then we turn it into a product and we sell it. And it works out pretty well for everyone. Now, in the past, we have presented on things like the effects of UV when deployed through flower development in cannabis. We've presented on lots of different applications for far red, deployed throughout the cycle or at the end of cycle or whatever it may be. We've talked about light distribution, and a lot of the time, what we end up doing is saying, hey, we are aware that there is a tremendous market interest in this thing. And there is a perception and a hope that this new wavelength of light is going to dramatically enhance yield or improve chemistry or whatever the case may be. And a lot of the time, what we see is that in our research, maybe we find a cultivar or two where that one thing that people are interested in tends to be true. But then when you deploy it with a lot of different cultivation styles and with a lot of different genetics, and particularly when you deploy those things at commercially relevant intensities, or in other words, intensities that would actually be relevant to your business, that thing is no longer true. It's a role that we play in the industry where we often feel like we're being the bad guy or a bit of a wet blanket, where we have to say, look, we do the research and these things don't add value for you, so we're not forcing it down your throat as a product, saying it's the greatest thing ever. So today is a very exciting thing for me because this red sandwich that we're talking about, this is a new lighting method, a new lighting technology that genuinely makes an enormous difference to your bottom line. You're going to hear me repeat this a few times through the presentation because I want you to really have these take homes sink in, but it's going to improve your quality, improve your yield. It's going to improve your uniformity, and it's also going to dramatically reduce your OpEx. I know it sounds too good to be true, and that's why with this presentation, we're going to walk through all of the sort of historical research that led us to this conclusion. And then we're going to tell you exactly how we deploy this thing and what we're seeing for the bottom line. Okay, so without further ado, like I said, if I can get my slides to respond here, just a minute. There we are. We are going to recap research that we've done on 4 different disciplines in cannabis cultivation, particularly with lighting. So, light intensity, light spectrum, light distribution, and genetics, and how all of these things interact to affect what ultimately is the best possible overall lighting solution. If you tuned into any of our research back in about 2020, we started out asking the simple question that probably a lot of you asked, which is what is the optimal light intensity for cannabis cultivation at scale? And we tried lots and lots of different treatments. We did a few different studies. And what we saw was that generally, cannabis follows this trend that all crops follow, which is that 1% more light in the form of PPFD, or photosynthetic photon flux density, will increase yield proportionally. 1% more light is 1% more yield. This is true in a lot of species, like I said, but the unique thing about cannabis is that it takes an awful lot of light before you get to the point of photosynthetic saturation. In other words, you can use more and more light and still have a proportional return on yield. And given cannabis is such a high value crop, there's a financial incentive for you to use as much light as you can. Now, I want to walk you through where this statement comes from and what you're seeing in this figure, because I know just seeing a figure with a bunch of dots on it is not particularly helpful without an explanation. So in this figure, you are seeing 3 columns, right? And pardon me. In those columns, you're seeing at the top of the column, you see R40, R60, and R80. This is describing the spectrum that we were testing in the study. So R40 refers to about 40% red, R60 refers to about 60% red, and R80 is 80% red. And the 3 rows in this figure that you're looking at are 3 different cultivars that we were looking at. So you see Bluebonnet, Skunk, and Waterloo, which at the time were pretty representative of what people were growing in the market. Finally, on the x-axis, you're seeing PPFD, so light intensity, and we've got data points here for 1100 micromoles per meter square per second and 1500. And what you're seeing is that obviously as light intensity went up in all of these cases, so too did yield. But you'll probably also notice that the amount that it went up is not consistent between treatment to treatment and cultivar to cultivar. For instance, in the top left quadrant, you see under the R40 spectrum with Bluebonnet, when we went from 1100 micromoles up to 1500 micromoles, yield went up about 18.9%. Conversely, if you look at the bottom right quadrant with the Waterloo cultivar, when we went from 1100 micromoles to 1500 micromoles, we went up 60% in yield. So pretty different responses. And that's an important thing to bear in mind. When you hear these claims like 1% more light equals 1% more yield for a given crop, those claims don't mean that literally every single time you grow a crop and make this adjustment to your light intensity, you are going to see exactly that response. These broad statements are usually the product of a meta-analysis. It's the product of a generalization that when you average all of the responses that you've observed, this is the trend that you see. Okay, so cannabis is particularly sensitive in this case because the genetic diversity in cannabis is so high compared to other crops. Therefore, from cultivar to cultivar or chemovar to chemovar, you may see different responses. But again, on average with cannabis, 1% more light is 1% more yield to a very, very high PPFD. In fact, I'll show you this next figure. In the one study that we did just with the R4 spectrum, or BW4, or Physiospec Indoor, it's all the same spectrum, just had different names over the years. In this study, we went all the way up to 2,500 micromoles. And across the 3 cultivars we were testing, we saw that 1-to-1 yield response start to taper off around 2,100 micromoles, with one of the cultivars actually just continuing up in a linear way. And at that point, in that study, we had so much light in that room. We had maxed out the electricity we could put in our research lab, and the entire ceiling was just lights. And so we said, okay, that's probably as high as anyone's ever going to realistically go. It would be interesting to go higher, but it probably doesn't really make sense for a commercial lighting technology provider to really do that. The point is, cannabis can take an awful lot of light. All right, so let's move on. From there, we could talk about spectrum. Right now, spectrum is really important in commercial horticulture for a lot of reasons. Spectrum can affect yield, it can affect quality, but especially important in the cannabis industry because of how much light we're talking about. Spectrum can really affect the system efficacy, right? You hear us talk a lot about red light in particular, because if you're familiar with LED technology, you know that red photons and red diodes, I'm sorry, not red diodes, but red photons are cheaper to produce than other photons. Generally, it's a longer wavelength. Longer wavelengths of light have less energy. So the more input electrical energy you get into the system, the more red photons or long wavelengths that you can get out. So when you're driving around and you see greenhouses that have kind of this pink glow, it's not because that's actually optimal for whatever crop is being grown. It's just because red photons are cheap to produce and therefore it uses less energy, reducing your OPEX and theoretically improving your bottom line. Okay, so in cannabis, in our early days, we were the company that was always saying white light was best for everything, right? And we had this theory that when using white light, those photons penetrate deeper into the canopy because blue and red photons are readily absorbed at the top of the canopy, and that lower part of the canopy ends up just in the shade doing nothing. So our first couple studies, we applied white, red, kind of a pink, even like a red, blue blurple kind of thing that you probably remember from like the 20 teens kind of time. And what we were seeing was that lo and behold, white light was better. We were getting about 17% greater yield with the R4 spectrum than we were getting with anything else. And this was replicated. So we gave ourselves a pat on the back for how brilliant we were. And that was our messaging for a little while. With the passage of time, we did more studies, we tried more cultivars, and we tried different cultivation styles. In particular, we manipulated planting density and planting number. And with time and all of these different implementations of cultivation style along with light spectrum, we saw that actually the benefits of white light that we thought were 17% greater then became 8% greater yield with white light, and then became actually there's no difference. And so you've seen our messaging evolve over time, or at least I certainly hope you've heard our messaging evolve over time. And now we've gotten to the point where we say, you know what? It turns out spectrum, at least in terms of commercially relevant spectra, it doesn't really affect quality or yield. And by quality in this case, I mean your chemical profiles of cannabinoids and terpenes. All right, so to recap what we know to this point, thing one, cannabis can take an awful lot of light with photosynthetic saturation saturating somewhere around 2100 micromoles, although it might even be higher than that and it needs more research. And thing two is that really within reason, you can use basically whatever spectrum, and it's not going to affect yield or quality as it pertains to cannabinoids and terpenes. There are other quality attributes that I'm going to talk about in a second, but in terms of just your straight up cannabinoids and terpenes, it doesn't really matter. Okay, now light distribution. On the off chance that you are familiar with me at all, I guess, and the research that I've been doing kind of over my scientific career, you know that I've often said if you create a more uniform environment, you will end up with a more uniform crop. And this is especially true with lighting. My first cannabis research was actually on under canopy light, and you can find this published in Hort Science, where I said, probably if we use under canopy light, we will end up with a more uniform bud. And many years later now, obviously UCL or SCL, I'll use those interchangeably for under canopy light or sub canopy light. Those are common in the market now. And we've seen applications for intercanopy light and UCL where you really can add, pardon me, excuse me. Sorry about that. We've seen lots of applications where you genuinely can add considerable value to your crop by redistributing your light and creating a more uniform light environment. Now, whether you use intercanopy light or whether you use under canopy light, it depends on your application. There is a valid use case for both. Whether you are more comfortable with infrastructure being kind of up at working level or you prefer having it down on the table, there are reasons, pros and cons for both. And planting density also very, very much informs your distributed lighting strategy. But again, the big takeaway for now is that if we increase light uniformity, we see things like increased yield. In particular, if you have a dense canopy and you redistribute some of your top light to a sub canopy light, we consistently see a bump in total yield by about 7%. And again, in this figure, you're seeing a comparison between intercanopy light and sub canopy light. In this particular study, in this particular distribution of plants, we saw that sub canopy was clearly the better solution. We also see some interesting morphological advantages to distributed light versus just having a really high intensity top light. Things like re-vegging and foxtailing are more prevalent when you have just a sort of sole source high intensity top light versus a more distributed lighting strategy. Okay, so let's recap one more time. Now we know cannabis can take a lot of light. We know that spectrum in terms of yield and in terms of cannabinoids and terpenes doesn't really matter. And we know that more distributed light gives you a higher value crop, which by the way, I think I forgot to mention, but when you have more distributed light, not only are you increasing yield, you are also elevating bud grade, right? So those C buds become Bs, Bs can become As. But also, this is not mentioned super often. There are some cases where As can also become Bs, and you just end up with a very uniform B canopy. More on that later if that's something that you want to talk about after the fact. We also have lots of research on that, and we can follow up after. Okay, so now let's talk about some interesting interactions, right? Because all of these factors in isolation is not the reality of how you grow plants. When we look at intensity and spectrum, like I said, it didn't seem like spectrum really mattered for some of the obvious metrics, yield and quality. But I'm sure you've heard Fluence talk a lot about photobleaching over the years. And photobleaching is this phenomenon where your upper inflorescences or buds, they turn white. They get this kind of beige brown appearance when they're dried down, and the chemistry is not affected. And in sensory panels, they cannot tell the difference between a bleached and unbleached bud, at least in terms of how it makes people feel, the smell and the aroma, all that stuff. But it kind of obliterates the value on the shelf. Just the bag appeal is pretty bad. People don't want to buy a photo bleached bud. So it's important to understand what causes it and how to avoid it. Generally, what we're seeing is that photobleaching is induced by the absolute flux of red photons. And specifically, we think that that flux density for just red, the threshold is around 500 micromoles of photons per meter square per second, plus or minus about 100 on either side, depending on your genetics. So, for instance, there are some cultivars like White Rhino or like Godfather that we've grown that are a little bit more susceptible to photobleaching, and so we know that that red photon ceiling is more like 400 micromoles. And then there are some cultivars like San Fernando Valley that we've grown the entire crop cycle under high red, and it didn't bleach at all. So you need to take this guideline with a bit of a pinch of salt. And this is not the point of today's webinar, but we do actually have some interesting dynamic scheduling stuff that we are aware of now that can allow you to use high red and still avoid photobleaching. So if you want to learn more about our T48 spectra on the Raptor 2, follow up with me. But again, not the point of today. Right. So that's the interaction of spectrum and intensity. And we know that if we use too much red from top of canopy, we are going to induce photobleaching. And that's too bad because, like I said earlier, the more red you can use, the better your system efficacy is going to be, and therefore the lower your OPEX is going to be. Now, what about when we look at intensity and spectrum and light distribution? In other words, what happens when we study spectrum with intercanopy or subcanopy? Well, it turns out with intercanopy, if you apply too many red photons, you induce the exact same thing as what you'd see with top light. You get photobleaching on the bud that is exposed to too much red. So that's kind of exactly the same. And with ICL, you can't use a high red. But this changes when you talk about UCL. With undercanopy light, using too much red does not induce photobleaching. Or said a different way, you can't use too much red with undercanopy light. And this is a very, very big deal, right? This is kind of the key that brings together years and years of research into something that is a genuinely revolutionary change in how we like cannabis. So with that, I can recap what we know so far, right? We can say if cannabis yield is almost always linear up to around 1500 micromoles, which by the way is on the more conservative side, you can go higher. If under canopy light improves bud grade and uniformity, and red fraction generally doesn't impact yield, but we know that too much red on top of the canopy can induce white tips or photobleaching, and red from the bottom doesn't. And lastly, red photons are dramatically cheaper to operate. Then does that just mean we should be putting an awful lot of light with a lot of red at the bottom? Sounds maybe too good to be true. So here's what we've done. Here we have a conventional lighting strategy, and this is Fluence's BW4 spectrum, just deployed as a top light. And this is our baseline because, candidly, this is the globally dominant lighting solution in the market worldwide. It has been for about 8 years. So this is what we compare to. If we take this and then we add a relatively high photon flux of a high red spectrum like Fluence's BP8 from the bottom of the canopy, and we do this in a way where we are redistributing the total amount of light that we're applying to the crop. That means that if we've added light to the bottom, we can subtract away some light from the top. But that also means that our total flux from the top is now low enough that we can shift that to a higher red solution, right? Without exceeding that red light limit for top light that we know is going to induce photobleaching. In the simplest in the simplest implementation of this, we can deploy about 50% of the light from the top and 50% from the bottom. And this is what we call the red sandwich. Now, I want to give you context for what this really means for energy savings, right? So if we rewind time and we look back to, let's say, about 2017, if you're using an HPS lamp, chances are that had an efficacy of about 1.8 micromoles per joule. If you then go ahead a couple of years, and you've moved on to what again is the most prominent light on the market, which is Fluence's BW4 spectrum, now you're at a 2.6 micromole per joule efficacy bump. That at the time probably felt like an enormous difference in your bottom line. Now, if you were to go from that to red sandwich, you go from 2.6 up to 3.4, right? This is a comparable jump. Going from a conventional LED top light solution to going to red sandwich is kind of like going from HPS to LED. 3.4 is a crazy number. In the world of commercial horticulture where they don't have to worry about photo bleaching, if someone was getting a 3.4 system efficacy on tomatoes, they would have felt pretty good about that. A year ago, if you had asked somebody if they thought this was possible in cannabis, they would have said probably not. If you had asked me 2 years ago, I would have said probably not because photo bleaching. And until the genetics catch up that they're not sensitive to red, we're kind of capped with white. So red sandwich is super, super exciting and genuinely changes the way that people are growing. So to say it a different way, moving from a top light white light like Fluence's BW4 spectrum to red sandwich reduces your lighting OPEX by about 21%. And the other thing to know is that this is safe for the majority of cultivars out there. So all cultivars that we consider to be low or moderate in their sensitivity to photo bleaching. And we think this represents about 75% of the genetics out there. And lastly, to recap the big takeaways of why red sandwich, well, again, it's going to increase your yield because we know that redistributed light from top of canopy to a distributed strategy with sub-canopy light does increase yield for the same total photon input. We know it can increase quality by elevating your C's to B's and your B's to A's. We know it works with most genetics, and we know it significantly reduces your OPEX. So again, in terms of your bottom line, red sandwich is a revolutionary way to light cannabis, and we really hope that you guys are as excited about it as we are. So that was about 25 minutes of a lot that I can just sum up with one card here. So what is it? Red sandwich is a cannabis lighting strategy that achieves an efficacy of 3.4 micromoles per joule while maintaining quality, yield, and improving bud grade and uniformity. How do you do it? Well, in its simplest implementation, it's 50% of your total flux of BP8 as top light and 50% of your total flux of BP8 as an under canopy light. And the return on investment is a little bit too complicated to communicate in this slide because it depends on your specific energy utility rates. But at least in terms of your OPEX, you're going to save about 21% compared to conventional BW4 top lighting. So with that, I would be more than happy to dive into any Q&A.
Good stuff. Thanks, Dave. We do have a couple of questions in here. Let me flip back over. And as a reminder, as we go through these first couple of questions, if you have additional questions, go ahead and hit the Q&A button at the top. Questions are moderated, so you might not see it right away, but rest assured we'll get to it as we have plenty of time here this morning. First question I got, just a point of clarification. When you talk about yield, Dave, does that mean total biomass or sellable flower?
Yeah, great question. I should have said as much, actually. I'm talking about sellable flower.
Short and sweet. Love it. Um, and I figured this would be a good one for you, just given your background. Can UCL be an effective for lower value crops such as cucumbers, tomatoes, etc.?
Oh, yeah, absolutely. So I know this is not the audience, so I'm not going to go on about this too much. But for these lower value crops, yeah, intercanopy light or depending on your cultivation style, under canopy light is hugely important. Anybody that's walked into one of these like commercial high wire crops, crop facilities, I should say, it's kind of silly, honestly. Like you go in and there are these gutters that are about waist high, and then the vine crops whether it's tomato, cucumber, bell pepper, they grow up to the top of the greenhouse that's maybe 12 to 15 feet up. And there's some supplemental top lighting and there's sunlight. And typically in those crops, they're supplementing like 200 micromoles of photons, so like a trivial amount of light compared to cannabis. But the silly thing is that as you walk through these walls of plants, you see lots of light at the top, and it's like the Shadowland. It's like the elephant graveyard from Lion King down there. It's like there are no photons getting down there, but you still have all these big leaves, especially with cucumber. You've grown these big solar panels basically for plants that are doing nothing. So it's a huge waste of investment. If you have those crops and you do add some intercanopy light, that dramatically enhances yield um, for the same total photon flux, or you can get a disproportionate increase in yield. And again, I got to be careful not to go on about this, but Fluence did do quite a lot of research on this a few years ago. And I'm always more than happy to go back and talk about that stuff if that's interesting to you. For now, I'll just say adding intercanopy light with those crops is really, really important and really valuable. There's a great ROI. And that's slightly different than what I'm saying in cannabis. With vine crops, I'm saying add light, right? So keep your top light the same, but then add photons with intercanopy light. Whereas with cannabis, I'm saying know what your target total photon flux is and then redistribute that light between top and bottom.
Makes sense. How about this? In these studies, or specifically the red sandwich study, were we adding CO2 to the environment, or
Yeah.
what was happening there?
Yeah. In all of our studies, we weren't explicitly adding CO2 for the experiment, but we're always running our experiments between 1,000 micromoles and 1,800 micromoles, depending on what we're studying. In those facilities, we're always running at least 1,000 parts per million, more often about 1,200 to 1,500 parts per million.
Got it. A lot of questions starting to file in now too. And I feel like I didn't even have to look at the name of who asked this one. Have you looked at using UCL without any top light? What do you think would happen to the plant there?
I can guess who that might have been. I think it depends on the environment. And I'll start by saying I don't explicitly know because we haven't tried that. But I think I think depending on the total photon flux you're talking about, it'll work. I think it'll grow a plant and you will produce flower, like sellable flower, and I think it'll be fine. But I think your morphology could get a little weird. Um, the reason I'm so wishy-washy on this question is because, like, first of all, hear me out. If you're in a greenhouse, you are getting some top light, right? And that's going to come from the sun. And the ratio of top light you're getting from the sun versus sub canopy is going to give morphological cues. Um, Secondly, if you are in an indoor facility, whether it's multi-tier or single tier, whatever the case may be, um, morphological responses in plants are also very much a product of photon flux density, right? It isn't just a spectral response. Um, so I think in this case, if you had like a really high intensity subcanopy light, you may, surprisingly, I would hypothesize you would have a more quote unquote normal looking plant versus if you had a relatively low photon flux from the bottom. Um, and this is why, for instance, like if you ever see studies on cannabis, especially from academia, where they say, well, we used far red and we had a lot of stretch, or we used blue or UV and we had a lot of compaction. That's because those studies in academia, they're often limited by the power available. And the total flux that they're applying to the crop is a little bit low for cannabis. It's more like 400 to 500 micromoles total. And again, at those ppfds, the plants are more sensitive to morphological signaling based on spectrum. So again, I'm giving kind of a long answer here because I think it's a really interesting question that I don't know the answer to, but there's a lot bouncing around in my skull for what I want to say about it. I guess the short answer is I think depending on ppfd, you could get some interesting morphology. Uh, and also your pruning strategy, right? That would also change a lot. I think there are a lot of factors that would interact and be at play there, but I think you would get a sellable flower out of it.
Interesting. Maybe a good segue into this. So I know we've done a lot of studies in the past regarding, maybe the ceiling for PPFD and cannabis.
Yeah.
Um, is there any change, or what's the maximum PPFD that can be achieved with red sandwich? Are we going
Yeah.
above what we know?
Yeah, also a really, really cool question. Um, so the maximum ceiling, I don't know. Um, and I had to, as I was going through the webinar, I had to word this somewhat carefully because although I say, the simplest implementation doing 50-50 top and bottom, there are so many other ways that you can do this uh, and use more red or less red and higher PPFD and low PFD and all these things, depending on what your goals are. So look, to answer the question in its most literal sense, the ceiling for photosynthetic response in cannabis, again, I think is around 2100 micromoles of photons per meter squared per second. And I say that based on our early light intensity research. Having said that, that light intensity research, we ran into a proverbial ceiling when we were short HVAC capacity. We were just driving so much transpiration with the plants that we couldn't keep up with the humidity load. And I think that may have stifled photosynthesis a little bit. But again, it was also one of those things where it's like, well, no one is going to do this, and it's not commercially viable to up your HVAC to deal with these loads. Um, the other thing is that it depends on your canopy architecture. So if you have a really big bushy plant and a really dense canopy and you're applying a ton of light, let's say you're applying 2000 micromoles from top, chances are you're going to photosynthetically saturate the top of canopy before the bottom canopy. And that invites opportunity to drive even greater yields by adding light to the bottom, right? So if you've saturated the top and you say, well, I guess I can't add any more light, that's really only true of those upper leaves and upper inflorescences. If you then add light to the bottom, you could drive net greater photosynthesis and therefore net greater yield because you're utilizing more of the plant. You're utilizing more of those solar panels that I talked about, which are what the leaves are. So what that means for red sandwich, again, it becomes a little bit complicated because I think you could do a top light and sub canopy or under canopy lighting strategy where theoretically you could drive things very, very hard. It wouldn't be red sandwich anymore. It would have to be probably white sandwich because, again, the real challenge with cannabis is that you can't use too much red at top of canopy without bleaching the top. So I suspect there's a scenario where you could use a really high intensity white light like R4. Like I said, we did our research all the way up to 2500 micromoles and it worked great. Didn't get photo bleaching even. So figure that out. But I think you'd probably still use a pretty high red spectrum on bottom just so that you have better system efficacy. It's a study I would love to do. If anybody has a research facility and some space they want to give me for free, give me a call. I'm always into that.
Awesome. Maybe another point of clarification. How about using red sandwich strategy? Is this both veg and flower, full cycle, just
Yeah.
flower?
Yeah, that's a good question. So the context of this webinar was focusing on flower, specifically because that's the more challenging part of the crop development cycle to optimize lighting for. During flower, that's when you have things like that's the sellable product in the end of the flower, right? So we need to make sure that we really maintain all aspects of yield and quality. Early in this presentation, I talked about spectrum and how it does not affect, or using too much red doesn't affect quality as it pertains to cannabinoids and yield. But later in the presentation, I did say that it affects quality in terms of the appearance. So red sandwich is a strategy specifically developed for optimized lighting during flower. Having said that, you can do it during veg. It's just that your lighting considerations and your production goals during veg are so different. During veg, you're probably targeting PPFDs up to 600 micromoles, maybe. Obviously, it varies from grower to grower, but let's say 600. For one, that's just not that high with cannabis, but also you're not actively developing flower during that time, so you don't have risk of photo bleaching flowers because they're not there. So by default, you can already use quite a lot of high red during veg. Like you could use an R8 top light, and you're going to get the same vegetative plant at the end of that veg cycle as if you used a white light. Um, the only differences that we've seen is like between a high red spectrum and a high white, or I guess a low red spectrum during veg, is we see a morphological difference in height by literally 1 to 2 centimeters. And that's in like a 3 week veg. So we consider that to be basically trivial, honestly. And we would just say use high red as a top light for veg just to save on OpEx. I don't really see an advantage to using any kind of UCL solution in veg right now.
It's fair. Um, a lot of good questions still coming in. Maybe a time to educate. So why is red light the cheapest photon to produce?
Oh man. Look, I can give you the answer that I have as a plant scientist. Um, a diode engineer, whatever that is. uh, they'll be able to tell you better. But there are two reasons. One is that just the technology itself is very well optimized. Red diodes are in everything. Um, in particular, the 660 nanometer red diode that's often in horticultural lights is the same 660 diode in broad strokes that's used in like car tail lights. Um, so it's just super, super common, which means that the technology of that particular diode and wavelength is well developed and made to be cheaply operated. But the other thing is that again, red photons in like the range of the visible spectrum, you go from blue to red. Blue are shorter photons and they're higher energy photons. Red are longer photons and they're lower energy. So for every unit of electrical input, uh, you can get out more longer photons, so more red photons, just because they require less energy.
Great. How about this? And so this strategy, and I know this is going to be one that's kind of different for every grower depending on what their cultivation style is. But with red sandwich, does this change the need or strategy and outcome for like defoliation since you're lighting the under canopy area? You need to make room for that light to get through.
Yeah, another really good question. So that's one of the advantages that we see with under canopy light versus inter canopy light. Generally, no, right? Generally, no. There are caveats to this, as always, but with under canopy light, those photons are shining up and they're going to hit basically the bottom surface of your canopy. Obviously, it's not a perfectly uniform plane, but neither is the top of the canopy, right? We treat these things, though, from a lighting design standpoint, we treat these things like uniform planes. And, our under canopy light in particular is designed to have, it's like a really wide beam optic, so you get really good uniformity. And what you end up with is that light getting to a lot of leaves that will use it. And that's important because what we saw with intercanopy light was that when you deploy intercanopy light in a canopy grown in like a sort of North American high density style, what was happening was that the light was getting stifled very quickly, right? If you can imagine this sort of light tube running down your plants and then just imagine any dense canopy you've seen all over that tube. What was happening was that, yeah, okay, we were getting a little bit of an uptick in yield um, because we were adding energy to the crop, but we weren't really seeing elevated uniformity and we were seeing a lot of bleaching because like a lot of photons were getting to the things immediately around that light and not really anywhere else. So, with all that context in mind, to answer the question, do you need to change anything about your pruning strategy? I'm going to say not as much as you might think. You can leave a lot of those lower leaves on, and they're going to be healthy and productive leaves that ultimately are driving biomass into your sink tissues, which in this case are your buds or inflorescences. We've done a little bit of research on this and found that it can affect your pruning strategy just in terms of scheduling, which I know is a bit more of a qualitative thing than the kind of quantitative things that I prefer to talk about. But like we've gotten feedback from growers that when they use sub canopy light, which would be the case with red sandwich, because their crop stays healthier longer in those lower tissues, they are not subject to the whims of the plant, right? They don't have to get in there and react to the plants when there are things that are dying off. They can choose on their own schedule when they go in and prune. I didn't realize that was such a big deal, but I've heard that from a couple growers now that that's something they really like about under canopy light.
Good one. How about this one? Um, and sorry if you don't know the answer. Doesn't the added cost of UCL fixtures undo any electrical savings?
Generally, no. That's a good question, though. These are all good questions. I guess I don't need to say that every time. So the specific ROI or return on the investment of the capital you invest to get under canopy lights, uh, it mostly depends on your energy utility rates. So, for instance, let's say you are in, I don't know, California, let's say, or I think Michigan also has high utility rates, and you're paying like 23 cents a kilowatt hour for your electricity. If you move to a system where you are dramatically reducing the energy that you're using, the ROI can be really, really fast, right? And it depends on your yields and it depends on the scale of your facility. But those ROI calculations, that's something that I and my team do on a regular basis. So if you're in this situation where you think, you know what, this could make a big difference for my business, and you're not clear on how to do that calculation and assessment, we're more than happy to help you with that. Um, and we do that calculation with you. It's not like we do some sort of secret math in the background. We will do the calculation with you. And if the economics make sense for you, then we'll say we recommend this. And if the economics don't make sense for you, we'll say, hey, here's a different lighting solution that makes way more sense. If you're somewhere where you're paying next to nothing for energy, then yeah, the ROI might not be as good. So it's one of those things we should assess on a case by case basis. But you should also bear in mind something like Red Sandwich does more than just reduce your OPEX. It also has all those other benefits in terms of quality and yield that I mentioned that increase your top line.
Hmm. Another good question, maybe another tough one. When we say quality, how are you defining that or increased quality? Are
Yep.
these, yeah.
Yeah. So the first quality aspects are cannabinoid and terpene profiles. We want to make sure that we're never reducing total cannabinoids and particularly total THC. So that's the first front of mind thing for me. And then the next factor is terpene, total terpene concentration. Because again, that's a lot of the sort of experiential aspect of consuming cannabis, right? In terms of flavor and aroma, and for some people, how it makes them feel. That is very much a product of how those terpenes interact with the cannabinoids. So we don't really want to mess with that. We want to make sure that we are only enhancing those things. Um, as a fun aside, we do have some lighting studies where we have identified spectra and spectral strategies where we can manipulate terpene profiles, but not necessarily increase total terpenes or decrease total terpenes. We can do things with spectrum where we can manipulate the ratios of one terpene to another. We haven't talked a lot about it because, frankly, that information doesn't have a lot of commercial value yet. But we know how to do it so that when the time comes, if and when there is a market demand for that, we will be able to make a product and obviously back it up with science. Um, but yeah, how we think about quality with Red Sandwich again is cannabinoids, terpenes, and then bud grade. Bud grade is huge. If we can do things like elevate C buds to B buds, that might take the market value from $300 to $700 a pound, or $700 to $1,000 a pound. Obviously, it depends on where you are in the world and what your market is looking for. But bud grade can be a big deal. We also look at bud architecture. So in particular, we look at individual bud mass and bud volume so that we can give you an indication of bud density. And we see both mass and volume have increased uniformity when we create a more uniform light environment.
Nice. Apologies if you've already addressed this, but I see it's come through this question or similar questions keep coming through. The studies regarding red sandwich, PPFD was constant from start to harvest. Um,
Yes.
correct? Okay. Sh- Quick
That
and
was that the
easy.
whole question.
That was the whole question. I've
Yeah,
seen
sorry.
similar
So let me
versions
let me
of.
give it. Sorry. Now that was a somewhat flippant answer. Let me give you a slightly better answer. So when we enter flower, we do ramp light up, right? So we start with our total PPFD matching where we left veg. And those specific numbers I actually don't have in front of me. So we can follow up and I can get you that. But we ramp up to whatever our target total PPFD is over the course of, like again, it depends on if we are doing a concurrent different top lighting using the Raptor T48 dynamic thing. So there's a lot of nuance that you can do there. But look, sorry, we ramp up over the course of a few days, and then we maintain a steady PPFD throughout. We've done some experiments where we ramp down at the end just to save on energy, but I think the jury's still out on whether or not that's really a value add thing versus just leaving your lights on the full time.
Excellent. You want to keep going? We still have a little time.
I don't mind. I'm getting a little dry, so apologies to everybody that I keep going back to the water here, but yeah, we can keep going.
All right. Um, it's a different question. How does the red sandwich impact substrate ECE management and crop steering strategies?
I don't know. that's
Yeah,
that's
yeah.
that's a good question, but I don't
It's a
know.
different study. Yeah.
Yeah, but what I can say is that with Red Sandwich, we haven't had to change anything about our fertigation strategy. But I will also candidly tell you, we have not done like an EC like a pour through analysis to explicitly look at that. We haven't looked at nutrient uptake explicitly. We haven't looked at root zone temperature. Um, and that last one in particular, I have heard from other lighting providers some claims about how subcanopy affects the root zone temperature and whether that's good or bad. We haven't looked at it, and candidly, I don't know enough about that personally to comment on whether that is beneficial or inhibitory. But again, what I could say is with all of our UCL research, we haven't had any issues with root zone stuff.
Fair. Um, so I know our studies was a single tier application. Have we tested this in a multi-tier scenario?
Yeah. Not that I know of. So we have. I meant to mention this by the way earlier in the webinar. We have commercial implementations of Red Sandwich underway right now, and although I didn't mention them in the webinar today, you should actually stay tuned because in a few weeks we're going to do a follow-up webinar on this to share the stories and experiences that people have had with this strategy in commercial environments. Um, I can't remember. I don't know if we have a multi-tier commercial trial on right now or very very soon starting. Having said that, I don't expect. I can't think of a reason why this wouldn't work in multi-tier. Or said differently, I fully expect this to work in multi-tier. Um, you have to be mindful of all of the things that you always have to be mindful of in a multi-tier environment, right? Multi-tier is a little bit more challenging in that you can have a lot of microclimate stuff going on from shelf to shelf. In particular, we see people sometimes run into airflow issues where they just don't have sufficient airflow between their different tiers. And what happens is that they get kind of these pockets of humidity. And when they have pockets of humidity, not only are you inviting more pathogens to set up shop and reduce your yields, but you're also reducing the CO2 that's getting to those plants. You're also reducing transpiration and gas exchange. So with multi-tier, excuse me, if you're not managing your climate appropriately, your yield suffers. When you add light, either by keeping your top light the same and then adding sub canopy light, or when you are doing something like a red sandwich strategy, that could be a scenario where you're still adding more energy than you had previously in that shelf. That is going to change the amount of transpiration those plants are doing. And so I would keep a very close eye on my temperature and humidity in each shelf. But as long as those things are managed and you have sufficient airflow, I would expect this strategy to be very successful in a multi-tier.
Yeah, great. I really like this one that came in. And while you're hypothesizing, how about red sandwich? Would it work in a no veg cultivation situation?
That's such a good question. Did Dominic ask that from an EXO?
Yeah, good guess.
Yeah, I had a feeling. So probably. So let me again explain my hesitation and my pause and stuff, right? And I hope the people that are here they've seen our webinars enough to know that everything that I say I want it to mean something, right? I don't want to just throw out whatever whims. Like I really want to give good answers. So if I pause and think about it and seem like I'm bouncing around, just please humor me and understand that it's coming from a good place. With no veg, you have plants that are a much shorter stature, and consequently, your light uniformity from the top of that canopy to the bottom of the canopy is actually going to be much better than a conventional cultivation style, right? We're talking about plants that are maybe like 1 to 2 feet tall in some cases with no veg versus, plants that are 3, 4, 5 feet tall. So again, if you already have good light uniformity, you're not getting some of the advantages that you otherwise get with a more distributed lighting strategy. Having said that, with no veg, to my knowledge, and Dominic, do correct me if I'm wrong about this, but I believe you are still pushing with very high PPFDs once those plants are starting to bulk out. Because again, to my knowledge, they can take it and you get a proportional increase in yield by going to a higher intensity PPFD. In that case, you are going to run into the same issues of photo bleaching if you use too much top light with too much red. And in that case, you can still achieve a high PPFD with high red if you use a red sandwich strategy by reallocating a lot of that light to a subcanopy light, make that subcanopy light red. There are some caveats to that as well. I'm not going to elaborate on that right now because I don't want to hang on this question too long and waste people's time. But uh, if you move more red light to the bottom of the canopy, I think you will then be able to shift your top light from white to red. Uh, but I would love to actually look at that more explicitly. So Dominic, let's talk.
Excellent. Well, we are approaching the top of the hour. And I guess before I kind of close us up here, Dave, any final thoughts? There's a lot of great questions in there. There's a handful that we probably don't have time to get to that we'll try to reach out after the fact. How can people contact you, Dave, if they have other questions or contact the team?
Yeah, sure. There are a couple ways to do it. I mean, there's the support page on the Fluence website, but if you want to reach if you would like to reach me directly, I didn't put my email on the slide. Sorry about that, but it's dave.hawley. You can see my name on my video feed here, so Hawley. Dave.hawley at fluence-led.com. And then, I'm happy to answer whatever questions you might have, or I can direct you to somebody on the team, whether it's a product specialist or one of our plant specialists or an engineer if you have a more technical question. We'll get you where you need to be.
Very good. And if anybody missed it in the first portion of the webinar today, it should only be a couple of days before we publish this entire recording on our YouTube channel, as well as the website. So if you'd like to rewatch or forward it to folks in your network, that's where you can do it. So be on the lookout for that. I'd love to see that here in the next 42 to or 48 to 72 hours. So be on the lookout. And if you are in Minnesota and are Minnesota cultivators, we are at the Lucky Leaf Expo this weekend. So come by, say hi, ask more questions about Red Sandwich. We will do our best to answer those questions. And we look forward to seeing you there if you happen to be in town. Otherwise, thanks again, Dave, for your time. Thanks again to everybody who sat in and asked all these great questions. And as Dave mentioned a little bit ago, we will be having follow-up webinars on this topic in the coming weeks. So be on the lookout for that. And otherwise, thanks again, and we'll see you all soon.
Thanks, everybody. Have a great afternoon.
Bye-bye.